Assalamu alaikum dear students. I hope everybody is fine. I am Dr. Alevas and you are watching YouTube channel ALEVELCAMS. In this lecture we will discuss the complex number. So the question arises, what type of complex numbers are, and secondly, why we need the complex number. So the complex number, let's say the set of complex number is denoted by C, and it is a plane which with the x-axis and y-axis. The x-axis is called the real axis, y-axis is called the imaginary axis. So we call this plane as a complex plane. So let's say G be a complex number, then G can be written as A plus iota B, where A be the real part of G and B be imaginary part of Z. And iota is written as -1, where iota square equal to -1. We call it iota. An Italian mathematician Girolamo Cardano 1501-76. Girolamo Cardano is the first Italian mathematician who gives the notion of the complex number while solving the cubic polynomial for cube root of unity. So later on, Wessel, in the last of 18th century, he gives the notion between the correspondence of the complex plane and the complex number. Means there is a point P with the coordinate, let's say A and B. So he said that we can represent as A plus iota B. He was the man who gave the idea for the correspondence between the complex number and the point. Later on, the Riemann and the Cauchy play the very vital role to finding the complex integration, and the Riemann equation are also very important in the complex numbers. So to check the analyticity, differentiability, something like that. And after that, the Carl Friedrich, I think so, he is a French mathematician. At the last of the 18th century, he gives the proof of fundamental theorem of algebra, where fundamental theorem of algebra is the base of the complex theory, in which there are exactly n root for the polynomial in complex. Means if we have a complex polynomial of degree n, then we have its exactly n roots. So this proof was firstly given by the Carl Friedrich. So now we come to our theory of the complex number according to your syllabus. The complex number is denoted by A plus iota B, A real, B imaginary, such that A and B are the real number. When we combine these two, so we get the complex number. Wessel introduced that the point in a plane or a complex plane, they both are the same. So in a plane, the point has 1 correspondence with the complex number. Let's say this is the point P with coordinate x0, y0. We can write it as x0 plus iota y0, where x0, y0 are any two real numbers. So Wessel gives this representation. So dear student, now we study some of the operations in complex number and something like that. So if we talk about the operations, two complex number, let's say G1 is a complex number, A1 plus iota B1, G2 be another complex number, A2 plus iota B2. So we can add the two complex numbers G1 plus G2. You can add the similar real part in the real and imaginary part in the imaginary. If we subtract, there will be minus. We can multiply two complex number and A2 plus iota B2, such that real part multiply with the real, which is A1, A2, imaginary part multiply with the imaginary, which is B1, B2, and I will get iota square. So iota is square root -1, so iota square will be -1. So here we can place this one. Similarly, plus iota. If we multiply the real with this imaginary, I will get A1, B2, and similarly A2, B1. This is the multiplication of two complex number. Let's say G be a complex number, a plus iota b, and we can plot it in a complex plane. Let's say this is a plus iota b. This is a point whose complex number is a plus iota b. If I take it conjugate, means the notation used in your book is G star. Some books use the notation G bar and some use the G star. So G star is equal to a minus iota b, means conjugate is a map which send iota to minus iota. So dear student, if here is a plus iota b, this is a and this is b, when I take its conjugate G star, you have to take its image below the x-axis. So you have a minus iota b. Understand, if you have here iota, then you will replace, you will get this one. So it means, let's say G be a complex number, a plus iota b, you are taking its conjugate, you have a minus iota b. So take its conjugate again, means G double star, you have a, again replace iota with the minus iota, you will get plus iota. So a plus iota b, we can write it as iota iota. Understand? Now what we do here, let's say G be a complex number, can be written as this one, and if I add into its conjugate, so you will get 2 times a, or in other words, a can be written as 1 by 2 G plus G conjugate. What is a? A be the real number, real part of the complex number Z. So you can write from here 1 by 2 Z plus G conjugate. Understand? Similarly, if we write G minus G conjugate, so this is G conjugate, multiplied with the minus, you will get minus here and plus here. Add them, you will get 2 iota b. So b can be written as 1 by 2 iota G minus G conjugate. And what is b? B is imaginary part of the complex number Z. Now we talk about the modulo. Modulo of complex number Z is defined as the Z absolute, and it can be written as a square b square square root. So dear student, you can see from here G modulo square is equal to a square plus b square. So student, we can write from here, it can be written as a plus iota b and a minus iota b, or in another words, you can write from here a minus iota square b square. So with the formulation of a square minus b square, you can write it as, and the addition is commutative. Another point is, let's say we have two complex numbers g1 plus g2, you can write it as g2 plus g1. Similarly, if we talk about the multiplication g1 g2, it is same as g2 g1, and the distributive law also hold. You can write from here, let's say g1 g2 and g3 b3, any complex number. So you can write here g2 plus g3, which is equal to g1 g2 plus g1 g3. These are some basic rules that we know to start the work. Now we come to the exercise and solve some of its questions.